So let's get started here. All right, so just like I mentioned before, what are excluded values in rational expressions? Excluded values are the values that will make the denominator of a fraction equal to 0. Okay, so typically whenever there is a variable in the denominator, we need to be careful because there is a number that variable can then create the denominator that will give a 0, generate a 0. So we want to make sure not to use that. We want to exclude it, and that's why we call it an excluded value. All right. So what we're going to do is very similar to what we did last time, where we factor. We try to eliminate the common factors in the numerator and denominator by dividing them out. But if there is a set of factors in the denominator, we have to solve those for 0 because we need to find out what number is going to create a 0 in my denominator, and we want to make sure we exclude that. Okay. All right. So let's go ahead and start with number 1 here, example 1. Okay, so the instructions here is just to simplify each rational expression and state the excluded value. Okay, so here is our example 1. All right, well, if you look at the denominator here, it's 25. There's no variable there. So really, this one is not likely to have an excluded value because there's nothing I can plug into the denominator in the first place. It's just 25. Okay, so let's just think about, let me just try factoring first. If I factor the numerator, I'm probably looking for a GCF there because there's only 2 terms, and 15 and 25 are not perfect, right? Well, 15 is not perfect. So what we can do is say, okay, well, at least both of them have a GCF of 5. So we factor out of 5, we're left with 3m plus 5, okay? And then this is all over 25. Okay, so one option that we do have is to say, okay, we can still simplify the fraction because 5 over 25, it's still reducible. So if you divide the top by 5, you're left with 1. If you divide the bottom by 5, you're left with 5. So here you're left with 3m plus 5 all over 5. Okay, and so there is our simplified expression. We can leave it this way. Okay, there would be no excluded values in this situation because there's nothing in the denominator that's going to turn that 5 into a 0, right? You would need a variable there, first of all, to be able to find an excluded value, but there is no excluded value because it's just a constant, it's just a 5. Okay. Any questions there so far? All right. Okay, let's take a look at the next one then. All right, so we've looked at something like this last time, right? If you take a look at what m minus 1 is equal to, okay, that looks like a difference of squares to me. Okay, so when we factor this, okay, remember that this is the same as m times m, and 1 is the same thing as 1 times 1. So when we factor this, we want to have m plus 1 and m minus 1, okay, all over 1 minus m. Okay, so now you see that the m minus 1 and the 1 minus m look similar, but they're not quite the same yet. Now, because I do have this factor in my denominator, there is a value there that if I were to plug something in for m, it would turn my denominator into a 0. One of the ways to do that is just to take that factor, 1 minus m, set it equal to 0, and when you solve for it, okay, when you solve for it, it'll tell you which value of m you're going to want to exclude. Okay, so here, if I want to get m by itself, I can add m to both sides. And I'm left with 1 is equal to m. So m equals 1 is my excluded value, right? So you can just list it in a curvy bracket, and you can just put in a 1 here. And 1, I know that by putting it inside those brackets, I know that you're referring to those being my excluded values, all right? So now that I know what the excluded value is, now I can try to see if I can still go ahead and factor this out, factor it out in a way where I can then divide the m minus 1 with the 1 minus m. Okay, so similar to what we did last time. What I needed to do last time was I needed to factor out a negative, because right now I have a 1 which is positive and m which is negative, right? And it's opposite, right? Here m is positive and 1 is negative. So I need to factor out a negative from my denominator here. Okay, so if I do that, okay, I still have m plus 1 times m minus 1 Okay, I'm going to factor out a negative, and I'm also at the same time going to flip them around so that they're in the right order. Okay, so basically think of it as, instead of, what if I rewrote it this way, right? Negative m in the front and then followed by positive m, and then I factor out a negative. So when I factor out a negative, I'm dividing everything by negative, so now that becomes a positive m and then a negative 1. Okay, do you guys see what I did there? I switched it first so that when I factored, it would then be in the correct order. Okay, see, thumbs up, good. All right. Okay, so then from here, what we want to do now is go ahead and cancel these two factors out, and then we will be left with m plus 1 divided by a negative 1. Okay, that's okay if you're dividing by a negative 1, because if you divide by a negative 1, it just makes the numerator negative as well. So this could also be the same thing as negative m plus 1. Okay, it's the same thing. All right, so then this would be the simplified version of your factor. Okay, so that's your factor there, and then the excluded value is 1, right? So if you were to plug in a 1, just think about what would happen. If you plugged in 1, you would have 1 minus 1 here in the denominator. 1 minus 1, that gives you 0. That's not a value that you want. Okay, so we are going to exclude it from this rational expression. Okay, so a two-part question, right? So you try to find the excluded values and you still try to simplify it as much as possible. So even though it cancels out, right? Even though it cancels out the m minus 1 over m minus 1, and you end up with an expression of just m plus 1, and you might think, well, if I plug in 1 to the final expression here, right, there's no problem because 1 plus 1 is 2, and then 2 times the negative is just negative 2. The issue is that the excluded value needs to honor what the original problem stated. So even though you end up factoring it out, when you get to negative m plus 1, at 1, right, when m is 1, you would have a problem there. So when you get to calculus, you're going to start to realize that these things become holes in the graph, which mean that in this case, let's say it was a line, right? Let's say you had a little graph. It's just like a quick sketch. What's going to happen in calculus is you're going to start to see stuff like this. You're going to have a line. It looks like a regular function, but then at a certain point, there's a hole there, and then it just keeps going, right? And why is there a hole? Well, it's because you graph this negative m plus 1, but the reason why there's a hole there is because, let's say this is 1 right here. At 1, there's an excluded value, right? So you see a hole, so you have to kind of skip over that part of the graph to keep going, okay? And that's kind of the idea, and you're going to see that in calculus a lot, all right? So that's just a preview of where this kind of goes later on. Okay, so if that didn't make sense, don't worry, because you'll see it later anyway. All right, let's take a look at number 3, I believe. We're on example 3 now. Okay, example 3, let's factor first, okay? We have 2 trinomials. We can factor this. I don't think they're too difficult, okay? So let's go ahead and factor this numerator first. So we know that's r squared. We want to factor that into 2 separate factors. So that's r times r. And factors of negative 10 that could add up to be negative 3, I believe we could do negative 5 and positive 2. Okay, that doesn't seem like it's too bad. Right, now in the denominator, r squared. So again, let's go r times r. Factors of negative 5 that add up to be negative 4, we could probably have negative 5 and positive 1. Okay, all right, now because I have 2 factors in the denominators, there's 2 possible r values that could get us a 0 in the denominator. Okay, so here, this is where you take both factors in the denominator. You're going to create 2 equations here. You're going to split these apart. Okay, only the ones in the denominator. In the numerator, it doesn't matter because it's okay to get 0 in the numerator. It's only a problem if you get 0 in the denominator. So you're going to take r minus 5. You're going to set that equal to 0. You're going to take r plus 1. You're going to set that equal to 0. When you solve for r equals 5, right? You would add 5 to both sides. And if you solve for r over here, r is equal to negative 1. So what does that tell you about the excluded values? That means that 5 cannot be part of an input into this expression, because if you did, you would have 5 minus 5 and you get 0. And then 0 times whatever you get on the other factor, it's still 0. The same thing happens with negative 1. If you took negative 1 and plugged it in for r, negative 1 plus 1 is 0. and 0 times the other factor, that's 0 anyway. Okay, so here you have excluded values. You have two of them. You have -1 and you have 5. So you want to list both inside of a set of curly brackets. Okay, so you found your excluded values. That's why it's important to factor first, find the excluded values, and then you can continue with the rest of your factor or your simplification. So you can see here that the two factors that would be eliminated would be r minus 5, right? So then your final expression there would be simply r plus 2 all over r plus 1. So again, you get a similar situation where the final product shows you that the excluded value should probably only be -1, but you have to take into account the excluded value that also got divided out. Okay, so that's why sometimes it's best to factor. As soon as you factor, find the excluded values, and then you continue by canceling. If you cancel first, sometimes you're going to accidentally skip an excluded value, and it'll come back to kind of bite you. Okay, because if you think about it, the excluded values, these two values would both give us 0 if you try to plug them in for r at this point at the very beginning of the expression. Okay, so even though they cancel out, the excluded values still exist. And then again, when you get to calculus, you'll see that on a graph that at 5, you're going to see on your graph there's going to be an open circle there. It's going to be a hole. All right, any questions so far? So we factor, you find excluded values, then you cancel at the end. Okay, are we good on that? All right, good. All right, sweet. Okay, let's keep moving. All right, number 4. All right, let's see. Numerator, doesn't look like there's much to do there besides maybe a GCF. So between 40 and 5, I believe it's just a 5. So let's factor out a 5. That leaves us with 8 minus b. Okay, all over. And now let's try to factor the denominator. Here we can factor this. Two factors. We have b squared, so that's just b times b. In order to get -32, but add up to be -4, that's probably going to be a -8 with a +4. Okay, so we can see here I have two possible values that are probably going to give me zeros in the denominator, so I split these into two separate equations. B minus 8 equal to 0 and b plus 4. And b plus 4 equals 0. Okay, so your two values for b that are going to create problems for you are 8 and -4, right? So these are going to be part of your excluded values, right? That's your set of excluded values. Now, if you look at the numerator and the denominator, they look similar. You have 8 minus b and b minus 8, but they're not quite the same yet. What do we need to do to one of them to make it look like the other? We've done this a couple times now. What do you think needs to be done? Yeah, let's factor a negative out, right? So we factor the negative out of either the numerator or denominator. I'm just going to go ahead and do it from the numerator for simplicity's sake. Okay, so that means, and I still have a 5 outside, but since I'm factoring out a negative, I'm going to bring that factor out in front of the negative. Okay, so it looks like -5. But really what I did is I factored the negative out of the 8 minus b. So I'm going to switch this around. I'm going to make it look like -b plus 8. Okay, so when I factor out the negative, when I take that out, now I'm left with a positive b and then a -8. And then my factors down here, it's b minus 8 and b plus 4. Okay. Do you guys follow what I just did there? This can be a tricky thing, so please let me know if you missed something, if you didn't quite understand it. Am I going too fast though? Or is it okay, Jose? Oh, okay. Yeah, it is pretty simple. It's basic things that we know already. It's just putting it together. Okay. All right. So we have our excluded values, and now that we factored out that negative, now we know that b minus 8 and b minus 8 can divide out, right? So now our final expression here, let me just go down here to the bottom, is going to equal, I have a -5. Since that factor got canceled, I no longer have anything else in the numerator, and then in my denominator, the only factor I have is b plus 4. Okay, so then there it is. There is my final expression. All right, let's keep moving. All right, couple things here for this one, right? Let's start by factoring the numerator, right? You have 3, 15, and 72. You might not see it, but there is a GCF there that each value can be divided by, right? And so in this case, that's going to be a 3. And not only that, but we have m to the third, m squared, and m. So since they all share m, we look for the lowest power. It's m to the first, so we're going to factor out a 3m. All right, then the rest of the factor is going to say m squared plus 5m minus, I believe it's 24. Yeah. Okay, 24. Okay, all over. And now in the denominator, when we have 4 terms, we talked about this last time, we're gonna have to do some grouping, right? So we're gonna split this down the middle here. And we're gonna look for the GCF of the first 2 terms first, and then we'll look at the GCF of the last 2 terms. Okay, so let me go ahead and do this here. So with the first 2 terms, they both have m in common, and they both go up to m squared at least. So then we can factor out m squared. Okay, that's going to leave us with m minus 2. On the other side, we're looking to factor something out as well. Because it's a leading coefficient that's negative, we're going to factor out a negative. And then 64 and 128, 64 is actually the GCF there, okay? Because if you multiply 64 times 2, you get 128. So that means both of these numbers can be divided by 64. So you factor out 64, that's going to leave you with m minus 2. Okay. So then that tells me that my new GCF is going to be m minus 2 because that's what's matching inside of the parentheses. Okay, so I can go ahead and bring over m minus 2. And then also m squared minus 64, these become the new factor. Okay, they combine to be the new factor. So that's m squared minus 64. Okay. All right, so we had a GCF in the numerator, then we still have a trinomial that we could probably factor, then another factorable expression in the denominator. I don't know if you guys see it, but m squared minus 64, difference of squares, right? So we're gonna have to factor that one more time. And the reason why I wanna do that first is because we wanna find those excluded values. All right, so let's continue factoring the numerator here. So we have 3m. I know that trinomial, because it's m squared, then that factors into m times m. And numbers that would multiply to be negative 24 but add up to be positive 5, I believe there that the combination would be positive 8 and negative 3. Okay, so 8 times 3 is 24, and 8 minus 3 is 5. Okay, in the denominator now, we still have m minus 2. Okay, but this m squared, that multiplies to be m times m, and 64 is 8 times 8, right? So we get m plus 8 and m minus 8. Okay, so in this case, I have 3 possible factors, so I'm going to have 3 different excluded values, all right? So there's 3 different equations you're going to want to write. You have m minus 2 equals 0, you have m plus 8 equals 0, and then you have m minus 8 equals 0. Okay, so here when we solve them real quick, you could add 2 to both sides, so m is equal to 2. Here you could subtract 8 from both sides, so m is equal to negative 8. And if you add 8, now m is equal to 8. All right, so now those 3 excluded values inside of your curvy parentheses, you can list them out as 2, negative 8, and 8. Okay, So there are your excluded values. Remember that the excluded values are the ones that show up basically in the very beginning of the rational expression. Okay, so those three values, if you plug them in, they're eventually going to give you a 0 there, okay, in the denominator. All right, so now that we're done with that, we've found the excluded values. Let's just go ahead and simplify whatever we can. In this case, the only common factor I see is m plus 8, so let's go ahead and simplify those two. So now what we're left with is a 3m times an m minus 3 all over m minus 2 times m minus 8, okay? And that's, even though it seems large, that's okay. There's nothing else that can be divided out. So that's the expression that we're left with. All right. Any questions on that part or that particular example? Okay. All right, I guess we're okay so far. All right, so now let's just head over to the last one now. Example number 6 here. And we probably just have something very similar. All right, so let's go ahead and let's tackle this. Example 6. Oh, tired today. All right, so let's start with factoring. Okay, we have a trinomial in the numerator. Let's see, GCF. Maybe a factor out of 2. That's about all that I see right now. So if I factor out a 2, we have 2x squared plus 5x minus 25. Denominator, I see here, they can all be factored by x at least, right? For sure that there's an x. And then I believe between 15 and 72, I think we can do 3. So if we factor out a 3, we're left with 5x squared plus 24x minus 5. Okay, so they're kind of, these are kind of ugly. They're kind of ugly actually. Okay, so let's see where this goes. Let's see where this takes us. Let's see if we can factor that numerator and that denominator. I don't know if that's going to be possible, but let's try. Okay, so let's go ahead. Let's do Xbox for the top here. We'll do this Xbox in red. Okay, so we're going to multiply these two factors together. That's going to give us a negative 50x squared, and it's supposed to add up to be 5x. So I think we can probably do negative 10x and a positive 5x, right? Do you guys agree? Okay, so they'll add up to be, actually no, maybe I have it the other way around. It should be a positive and that should be a negative right there. Yeah, that makes more sense. So they add up to be 5, 10 minus 5 is 5, 10 times negative 5, negative 15. That looks okay. Now let's go to the box here. All right, so the leading factor was 2x squared. The final was negative 25. We could put 10x and then also a negative 5x. All right, so let's find some factors here. So across on the first row, the GCF right here, it looks like that's only going to be x for us. In the second row, though, it looks like both can be divided by 5. So it looks like we have x plus 5. In the first row, I think we can do 2x. And in the second row, it looks like we could do a negative 5. Okay, so it looks like we can factor the numerator to be 2 times 2x minus 5 times x plus 5. Okay, that's our numerator for now. All right, denominator. Again, let's do an X box here. And we can multiply these two factors together. So negative 5 times 5 gives us negative 25x squared. And they have to add up to be 24x. So then this is probably going to be a 25x times 1x. One of them has to be negative, so I'm going to go ahead and give it to the smaller factor there. So 25 minus 1 is 24. 25 times negative 1 is negative 25. Okay, so now let's go ahead and move over to the box. All right, so our leading term in the denominator was a 5x squared. The last value was a negative 5. And the two factors here are 25x and negative 1x. All right, so let's see what we can have in common. Across the first row, looks like it's a 5, or it's an x there. They both share x. Second row looks like it's going to be a 5 only. Okay. In the first column, they can both be divided by 5, and then they both have x in common, so that's a 5x. And then between both of these, at least we can divide out a negative 1. Okay. So now in my denominator, what I can say is, and we'll bring down that 3x, I also have x plus 5, and then I also have 5x minus 1. Okay, so a little bit more work for this one because we had to do some Xbox there, but not too bad, not too bad, right? So now that everything is factored, remember that now is the time to look for the excluded values. So go ahead and set, in this case, you have 3 separate expressions or 3 separate factors. Don't forget to use this 3x here as something that you're going to set equal to 0, because there you're going to find a value that if x happens to be a 0, it will turn the whole denominator into a 0. Okay, so go ahead and split this up into 3 separate equations. So you have 3x equals 0, x plus 5 equals 0, 5x minus 1 equals 0. Okay, so if you divide both sides by a 3, x equals 0 here. If you subtract by 5, x equals negative 5. And if you first add 1, 5x equal to 1, then you divide both sides by 5. X equals 1 over 5. Okay, so we have 3 excluded values. I'm gonna put those in green down here. In those curvy brackets, we got 0, negative 5, and 1 over 5. Okay, so we want to avoid those 3 values. We're probably going to have some sort of hole there. And now then we can go ahead and factor or divide out the common terms. Those are the only common terms that we have. Everything else is uncommon. So we can go ahead and bring down our final expression as 2 times 2x minus 5 all over 3x times 5x minus 1. And there is our final expression. Okay. All right, and that's pretty much it. That's it for today's lesson. Okay, so again, it was just more of the same, but the only added thing there was how to find those excluded values. Okay, so you factor completely first. After you have factored as much as possible, you find your zeros. Okay, you find those excluded values, you list them. Okay, you put them in curvy brackets and you list them all, and then you can continue to simplify by dividing out the common factors. Yeah, they got a little long because of the factoring, right? They were not the easiest ones to factor, but not too bad. Okay. Any questions for me? Yeah, I can go back to example 3. Do you mean, yeah, I got you. You mean, let me put it like this instead. So the r's don't become one because it's not a product of r times 2 and a product of r times 1. Yeah, it's r plus 2 and r plus 1. So those two factors are completely different. So you couldn't cancel them out. The only time you could factor out r's is if like you ended up with something like 10r squared or something over 5r, right? The reason why is because there's a product, 10 times r squared and 5 times r. So because they are separated by the product, you can treat the r's separately. But once they're being added to something else, it's a separate rules. Okay. So yeah, if it throws you off, you just put the parentheses, keep the parentheses around it, and that usually gives you a little bit better idea of like whether I can cancel it or if I can't. So parentheses is super helpful in these types of problems. Okie dokie. Anything else? All right, guys. Thank you. Thank you. Yeah, thank you for guys for showing up. I appreciate it. I really do. Thank you for sticking through it. We only have like, what, after this week? Let me check my calendar here. 3 full weeks, and then it's like our final week. And usually the final week, it's, you know, it's the final week. So, all right, AP test for AP World. That's right. Good luck for those of you who have it soon. Make sure you're getting plenty of rest. No, it will not. It will not. It's okay. One test or 2 tests do not define your life. All right. So try your best. Do what you can. Hopefully you do well. If you don't do well, that's okay. You have everything to gain and nothing to lose, because it's not like, it's not like you're not going to go to college. It's just maybe you'll save yourself having to take a class. Okay. So just try to relax. Try to relax. Okay. You guys will do great. Okay. All right, guys. Well, good luck. Get some rest. I will upload homework shortly. Again, I will keep it to just like even problems so that I'm not overwhelming you with too much. Okay. All right. Well, I'll see you guys next week then. I'll definitely keep you posted on any announcements. So just stay tuned. Okay.